All right, we're going to go ahead and get started with another video. This one, like the title mentioned, is going to be covering example 8-25. It's from page 465. Okay, so the theme is outpatient surgery. A hospital administrator believes that the standard deviation of the number of people using outpatient surgery per day is greater than 8. A random sample of 15 days is selected. The data are shown. At alpha equals 0.10, is there enough evidence to support the administrator's claim? Assume the variable is normally distributed. So the first thing we'll do is we'll record the information that we're given. I have sigma is equal to 8. That's the number in question that we're thinking that is greater than, right? We have a random sample of 15 days. So that's our sample size is 15. And we have our significance level for our test is 0.10. All right. And then here, they don't give us the sample statistic. Instead, they just give us the raw data itself. And so here it's up to us to go through and calculate. Here we are interested in testing S. We're interested in testing sigma. And so we need to compute S, the sample standard deviation. So here I'll just write that down. I'll write it in blue so that you remember that I'm telling you that we discovered this. This was not in the problem itself. We have to calculate. So I'll just say we calculated this. Yep. All right. So there is all of the initial information, and we'll go into the hypothesis test. So in H subscript 0, sorry, that's not a 6. That's a sigma. It's hard to do. In H subscript 0, we have sigma is equal to 8. For H subscript 1, we're going to say sigma is greater than 8. So the hospital administrator is of this opinion, and so we're going to test it. All right. The claim is that the standard deviation is bigger than 8, and so we're just going to say, well, if we don't get any evidence, we're just going to walk away with the assumption that it's not bigger than 8, so might as well call it 8. All right. So there's our claims. All right. Then the critical region. Let's go ahead and find that. So here we have our sigma squared curve. Let's put in the chi-squared distribution. I'm sorry, not the sigma squared. We'll put in our degrees of freedom, and then we'll mark it off like so. Okay. We see that it is a right-tailed test. And so I want this area on the right side to be 0.10. And this value, we would actually call it chi-squared subscript alpha, or in this case, since alpha is 0.10, chi-squared subscript 0.10. We're going to be looking in row 14 for 14 degrees of freedom, and then moving on over to the column that corresponds to alpha equals 0.10. And so we get out 21.064. So we see where the critical region begins and ends. Next, we're going to calculate our test statistic. So the formula for chi-squared is n-1 times s squared, all divided by sigma squared. And so here, I'm going to substitute in 15 in place of n. Notice we calculated the standard deviation and came up with 11.2. Our formula calls for S squared. We calculated S, and therefore we have to go ahead and actually square that. So it is important to pay attention to whether you have S or S squared, whether you have sigma or sigma squared, all right? And if you have sigma squared already, for instance, then you wouldn't have to square it again. But here, the reason that I got 64 is because we had to substitute in 8 in place of sigma, and then we had to go ahead and square that. And so that's how we get 64. All right. Anyway, enough stalling. Let's actually get out the calculator. Yep. All right. So calculator says 27.44. Now we're going to make the decision. Well, look at our chart. 27.44 is in here somewhere. Okay. This is 21 right here. And so 27 is beyond that a little bit. So our decision in step 4 is going to be to reject the null hypothesis. And then we have to summarize the results, and we conclude that the evidence, or we conclude as follows. We say the evidence suggests that the standard deviation is greater than 8. So another example of doing the chi-squared test for variance or standard deviation is here in 8-26 on page 466, talking about the nicotine content of cigarettes. And it says here, a cigarette manufacturer wishes to test the claim that the variance of the nicotine content of its cigarettes is 0.644. The nicotine content is measured in milligrams, and we are going to assume that it is normally distributed. A random sample of 20 cigarettes has a standard deviation of 1.00 milligrams. At alpha equals 0.05. Is there enough evidence to reject the manufacturer's claim? Now, when we are looking at a hypothesis test, keep in mind, if they ask us, is there enough evidence to reject the claim? Is it not true that this is not the case? Or any time they say test the claim, do this, do that, it is never, even if it sounds like a yes or no question, remember, it is never a yes or no question. We're always going to answer the question in a complete sentence. We're going to just make it a statement independent of what their question was. And it will answer the question because we're going to include all of the pertinent information that we have found and presented. So here, remember, they ask us about the manufacturer's claim, but we really don't care about their claim whatsoever. We only, in our eyes, there is only H subscript 0 and H subscript 1. As to what the claim is or isn't, couldn't care less. It's sometimes helpful. So I take that back. Sometimes I can care about it. Like here in this instance, we're going to say that the cigarette manufacturer's statement that the variance for the nicotine content is 0.644. That is their claim, all right? But we're going to proceed with the hypothesis test the same exact way that we always do. So notice here, oh, that wasn't very good. Let's try this again. Yeah, close enough. Notice here we actually have a two-tailed test. So we have a little area on that side, and we have a little area on that side. So we have our rejection region is split into two tails. Okay, I'm going to go ahead and use 0.025 on this side. Oh, sorry, got that exactly backward. We're going to say 0.975 on that side, and then here this is going to be chi-squared of 0.25 because the area in this tail is 0.025, and the area underneath this tail is going to be the same, 0.025. And so remember, that means that the area to the right of that has to be 0.975. Okay. So looking up in our table, using 19 degrees of freedom and these critical values, 0.025 for the right side area for the one on the right, and then 0.975 for the right side area for the lower value, the one on the left. We get these, they're 8.907 for the small one and 32.852 for the larger one. Next, we calculate the test statistic. So chi-squared, same way, is n minus 1 times s squared, all divided by sigma squared. So here we keep in mind that we get 19 from doing 20 minus 1, sample size is 20, therefore the degrees of freedom are 1 less than that, 19. Notice we were given S is 1.00, so we technically have to square that. Versus here, they told us not sigma, but they gave us sigma squared. So make sure we don't square that one. And this works out as 29.5. 29.5 slides in just underneath 32. So we are not in the rejection region. Our decision is don't reject the null hypothesis. And so we say, well, whatever we had claimed or whatever we had proposed for H subscript 1, the evidence didn't support that. So we kind of basically just go back to H subscript 0 and say, well, I don't have any reason to throw this away, so I guess I'll accept it. And we'll summarize that by saying there's not enough evidence to say that the variance is anything different from 0.644. So we have not proved the cigarette manufacturer's claim, right? We're just saying that there's not enough evidence to throw that claim in the trash. That's basically it. All right, so we'll pause this. We'll stop here.